Good day, engineers. I am your Tito engineer, and today we will discuss the part 2 of our buoyancy problems series. Problem number 2. A piece of metal having a specific gravity of 7.5 is floating in mercury having a specific gravity of 13.6. Number 1. What fraction of the total volume of the metal is above the mercury surface? Number 2. If the volume of the metal below the mercury surface is 0.018 cubic meters, what is the total weight of metal in kilonewton? Number 3. What vertical force will keep the metal fully submerged in Kn? For our illustration, a simple drawing showing the floating metal will do. It is important to take note the volume of metal above the mercury surface and the volume displaced by the metal below mercury surface. For the first part of this problem, we were asked to determine the fraction of the total volume of the metal is above the mercury surface. For our solution to the part 1 of the problem, we will use the formula for volume displaced. Recall the formula for volume displaced, that is, volume displaced is equal to specific gravity of body over specific gravity of fluid multiplied by the total volume of the body being submerged. Substituting this to our working equation. It is important to take note the given information in our problem, that is the specific gravity of metal is 7.5 and the specific gravity of the fluid is 13.6. The fluid in this problem is mercury. Take note that it is also important to memorize the properties of fluid such as their specific gravity for water, mercury, and oil, which is by far the most used fluid in our board exam. Take note also that there are problems wherein specific gravity will not be given and we will be the one to supply it. Continuing, we have volume displaced is equal to 7.5 over 13.6 times total volume V. Simplifying it further, we can get volume displaced is equal to 0.5515 times the total volume V, but this is still not our final answer since we wanted to get the fraction of the total volume of the metal above and not below the mercury surface. From our illustration, we can get the total volume of the body is equal to the volume above the mercury surface plus the volume displaced or the volume below the mercury surface. Transposing the volume displaced into the left side of the equation, we get volume above is equal to the total volume minus the volume displaced. Since we already got our volume displaced as a function of the total volume V, we can now solve for the volume above. That is, volume above is equal to V minus 0.5515 V. Simplifying, we get volume above is equal to 0.4485 V. Since we are after for the fraction of volume above to total volume, we will divide both sides of equation by V. We get, the fraction of volume above to total volume is 0.4485. Or in percent, that is 44.85%. For the second part of this problem, we were asked to determine what is the total weight of metal in kilonewton if the volume of the metal below the mercury surface is 0.018 cubic meters. The illustration in this question is just the same as part 1. For our solution to the part 2 of the problem, we will use the equations we obtained from part 1, that is volume displaced is equal to 0.5515 times V. From the question, it is stated that the volume of metal below or the mercury surface or the volume displaced is equal to 0.018 cubic meters. Substituting it to our working equation, we get 0.018 is equal to 0.5515 times V. Dividing both sides of the equation by 0.5515, we get volume of metal is therefore equal to 0.03264 cubic meters. Note that this is still not our final answer since we are after for its weight. Recalling our formula for weight, that is weight is equal to unit weight times volume. The unit weight in this problem is equal to unit weight of water times its specific gravity. Substituting values, we get the total weight of metal is equal to 9.81 kilonewton per cubic meters times 7.5 times the volume of metal, that is 0.03264. Total weight of metal is therefore equal to 2.40 kilonewton. Additional tip, it is advisable to not round off your answers from start to end until you reach your final answer if it is possible. Store it to your calculator in order to arrive with the answers on the choices. Because in some, the choices will really differ from your final answer even if your solutions were right. Especially if you consistently round it off to, let's say, 2 to 3 decimal places. In my videos, I did round it off to avoid confusion. For the third part of this problem, we were asked to determine what vertical force will keep the metal fully submerged in Kn. The illustration in this question is just the same as part 2, but we will now draw its free body diagram since we are dealing with forces. If we will draw the free body diagram of part 3, we will identify the forces that our metal will be subjected to. First is the additional force F. We will just assume it to be downward. We can verify the orientation of the force along the way. If we got a positive value for F in our solution, then our assumption is correct and it is indeed downward. If we got a negative value for F, then our assumption is incorrect, indicating that the additional force must be upwards. Next is the downward weight of metal. Next, the force that will counteract these weight and forces to remain in equilibrium is the upward buoyant force. For our solution to the part 3 of the problem, we will use the same equilibrium equation. Summation of all vertical forces are equal to 0. With sign convention, upward forces being positive. Buoyant force minus weight of metal minus the additional force F. Recall the formula for buoyant force and weight. Unit weight of fluid times volume displaced minus unit weight of metal times volume of metal minus the additional force F is equal to 0. Now substituting the values, take note that from part 1, the volume of metal is 0.03264 cubic meters. Although this is the total volume of metal, this is already equal to the volume displaced since the problem states that it is fully submerged. Continuing, we got 9.81 kilonewton per cubic meter multiplied by 13.6 multiplied by the volume displaced equal to 0.03264 cubic meters minus 9.81 kilonewton per cubic meter multiplied by 7.5 multiplied by the total volume equal to 0.03264 cubic meters minus the additional force F is equal to 0. Transposing F into the right side of the equation, we got additional force F is equal to 9.81 times 13.6 times 0.03264 cubic meters minus 9.81 times 7.5 times 0.03264. Vertical force will keep the metal fully submerged is therefore equal to positive 1.953 kilonewton. Note that the positive sign signifies our assumption is correct, therefore the additional vertical force is a downward vertical force of 1.953 kilonewton. Part 3 for buoyancy problems will be posted next. Stay tuned. Like, share and subscribe to your Tito Engineer for more problems for civil engineer and master plumber board exam. Thank you.